Good morning to everyone. Today we are going to see what is centroid and what is center of gravity. Centroid is the center point of a plane surface area, maybe a circle, a square, or a rectangle. The center point of this circle or the center point of this square, the center point of this rectangle is known as centroid. So for a circle it will be d by 2 from one end. For area it is a by 2. Okay, this total distance is a, means this is a by 2. For here also, from here it will be a by 2. Whereas for a rectangle, this is the length and this is the breadth, L into B. Okay, so the centroid will be half the distance. There is L by 2, L by 2 from one end, and B by 2. So you get this point. So this is known as centroid. The center of a plane figure is known as centroid, two-dimensional. Okay, x and y. So coming to the center of gravity, the center of an object is known as center of gravity. It will be having three dimension like x, y, and the z. Okay, the center of the object or a body is known as center of gravity. Now we are going to see about how to find the centroid of a T section. Let us assume a T section which is 100 mm by 20 mm, the flange, and 60 mm by 10 mm is the web. Okay, so this T section can be divided into two regular surfaces. We can mark it as 1 and this is 2. The first section dimension is 100 mm length and 20 mm width. Okay, whereas the second section, it is 160 mm height and 10 mm width. So we are dividing into two portions, and one can be shaded like this. It's marked 1 and 2. Okay, this is the second section. First, what we have to do is we have to draw the reference axis. So this xx and yy is the reference axis, which is in the green color. Okay, then we are divided into two sections. We are marking the center point of this rectangle, first rectangle, and the center point means centroid, and the centroid of the second section, the second rectangle, we are marked over here. We have to find the centroid of the whole T section. Okay, so after drawing the reference axis, now we have to find the area of the first section and the second section. This is the first rectangle and the second rectangle. So area A1, okay, is equal to 100 mm into 20 mm. 100 into 20. So you get 2000 mm squared. Whereas the area of the second section, A2 is equal to 60 into 10. 60 into 10, that is equal to 600 mm squared. Okay, now we have the formula for finding the centroid. X bar is equal to x1a1 plus x2a2 divided by a1 plus a2, and y bar is equal to y1a1 plus y2a2 divided by a1 plus a2. So we know a1, a2, but we should find out x1, x2 and y1, y2. So what is x1 and x2, y1 and y2? From the figure, this is the first object. We have marked the centroid. Okay, so the distance from the reference axis is yy. The distance, this is known as x1. Similarly, for the second section, the centroid is over here. Okay, and the distance from the reference axis, this distance, is the x2. So you can mark it as g1 and g2. So distance of g1 from the reference axis and g2 from that is x1, and g2 from the reference axis, that is x2. And similarly y1, y2. So distance from this reference axis xx to the centroid of the first rectangle. So this distance is known as y1. So this is 60 plus half of 20. This is 20. Half of 20 is 10. Okay, this is 10. So 10 plus 60. 10 plus 60, you have 70 mm is y1. Whereas y2, it is, this is a g2. So from here, the distance from the reference axis xx to g2 is height. Totally is 60. Half of 60 is 30. So you have y2 is equal to 30 mm. And now we know x1, x2, y2, y1, y2. You can substitute the formula. This x bar is equal to x1 is 50 into a1 you know 2000 plus 50 is again x2, and a2 is 600 divided by a1 plus a2, that is 2000 plus 600. So you get, solving it, you get 1,30,000 divided by 2600. So x bar is equal to 1,30,000 divided by 2600. If you solve it, you get 50 mm. So 50 mm, that is from the reference axis. So from YY, 50 mm distance. So this is the XX axis. No, this is the YY axis. Okay. So this centroidal axis is 50 mm from the reference axis. Similarly, y bar we are finding it out. y1 a1 plus y2 a2 divided by a1 plus a2. So y1 we have found out already, it is equal to 70. This is 70. Okay, and y2 is equal to 30. You know a1 a2. Okay, y1 y2 is known, a1 a2 is known. So y1 is 70, a1 is 2000, y2 is 30, and a2 is 600. So you substituting it, you get 1,58,000 divided by 2600, that 60.77 mm. So y bar is equal to 60.77 mm. So you substitute over here and draw it in the diagram. So from this reference axis, 60.77 mm approximately over here. Okay, this is 60 mm. So 60.77 means about little above that. Okay, this is the x axis. So this is the centroid of this T section. Okay, little above this second section. You have to over here. So the main step is, first you have to divide the given diagram into regular sections. Okay, and then draw the reference axis, then find the area of each section, locate the centroid of each section, and find out the area a1 and a2, then find out x1 and x2 and y1 and y2. So the main points to be noted is, for finding the centroid of a T section, first we have to divide it into regular surfaces, that is two rectangles, and then marking the centroid of those two sections, that is G1 and G2, drawing the reference axis, and then finding the area of the first rectangle and the second rectangle, and finding out, that is a1 a2 is known. After that, x1 x2 y1 y2 we have to find out. So x1 is the distance from this yy axis to the centroid, that is G1 and G2. So this distance is known as x1 and this distance is x2. Similarly, y1 and y2 from xx axis, the distance of G1 and G2. So the distance from this reference axis to this centroidal axis, centroid of this first rectangle, G1, that is 60 plus 10, 20 by 2. You have 70 mm, and similarly the distance y2 is equal to 60 divided by 2. This is 60. Half of 60 is 30. So G2, the distance is 30 mm. Okay, thank you.